This is a I screwed up. No. This is a continuation of your 8.3. We're going to be dealing with an application of encrypted matrices. Really, we're not going to get into the encrypted matrices yet. What I'm going to teach you is another way of setting up a system of equations that's solvable by matrices. So this is our main focus, and then I want you to start thinking of how could you develop ideas of hiding messages within data. That's kind of an overall question for the end of this PowerPoint. So a quick review. When we had augmented matrices, when we would have a system, we had augmented matrices available for us where we would set up the system of equations into a matrix that looked like this. And all that matrix consisted of was a coefficient matrix and a solution matrix with a bar there. So for example, we use that to have a system like this set up into this form so that when you take the reduced row echelon form of it, we would get something very useful to us. So I just want you to kind of consider, why was this helpful for us? And recall that, review that, make sure that you know how to solve a system using an augmented matrix. So now we have a new setup. This is an alternative to an augmented matrix. What we're going to do is we're going to use multiplication to set up a system. So using multiplication, we're going to be using a coefficient matrix, just like the augmented, but this time we're going to actually use our variables in it, and then equals a solution matrix. So what I'm going to do is I'm going to use our coefficient matrix. These are our unknown variables that we're trying to solve for, and there's our solution matrix. Okay, so what I want you to consider is if I were to multiply these together, there is supposed to be multiplication in between here. What we would be saying is we have a 3 by 3 and then a 3 by 1. So yes, we can multiply them together, and then the expected dimensions of our matrix is going to be a 3 by 1. So that's going to be this thing right here. But what I want you to see is if we were to multiply these, this is what we would get. We're going to get a 1 times x plus a negative 4 times y plus a 3 times z, right? This is my first entry. Unfortunately, I can't simplify that, but that is my first entry in row 1, column 1 of that 3 by 1 that I am expecting. This second entry is going to be this C, so keep in mind I'm expecting something like this, a C1, 1, a C1, a 2, 1, and a C3, 1. So this second entry that's going to go right below this is going to be taking row 2 times column 1 of these two matrices that I'm multiplying. So it's going to be negative 1x, right, because I'm going to take those to each other, 3 times y, and then plus negative 1z. So what you can see here is I am starting to form what's going on up here. And then finally we're going to have 2x, 0y, and then negative 4z. So what we're basically saying is these things right here are going to be equal to, I was just using that as a guide to help me come up with those entries and what I was supposed to be multiplying. These are going to be equal to this. So now what your calculator is hopefully going to be trying to do, or what your matrices are hopefully going to be trying to do when you try to solve something like this, is what would fit these requirements that this top entry is going to be equal to 5. This bottom entry is equal to negative 3, and this third entry is equal to 6. When we set these up, we have an A, which we fully know, times an unknown matrix equals some sort of result matrix. What I want to do is ask you, how do you solve for this? Considering everything that we've learned in the last few sections, how can we get this x by itself, just a lonely x is equal to something?
So when you come to class tomorrow, prepare to discuss the following of how can we solve for this matrix? How can we get this by itself? Any ideas, any questions that come from whatever ideas that you come up with, we're going to discuss tomorrow. So our goal tomorrow is to get this x, y, z equal to some sort of value, and again, we just want this by itself. How do we solve for it? Forget that you actually do know the answer, since we did have that augmented setup. You can use that, but the idea is this we want by itself using this type of setup. All right, good luck.